Hi sir, everybody. My TLM name is Torchlight Microscope Projector. For this we need a foam sheet and a 15x eyepiece from a microscope and a torchlight and some slides. Then we need onion also. For this TLM, to prepare this, we have to make a hole like this, a gap, and we have to set the torchlight like this, and then we have to set this microscope eyepiece like this. Whatever the slide specimen we have to project on a wall in a classroom, we have to place it in between both of these like this. After setting like this, we have to lights. If you place like this, we can project the slide specimen enlarged image on a wall. So if you place like this, we can show the specimen cells whole class at a time. This is how we can place easily visible to every child in our classroom. Then we can make every children to understand the property of the cell, the specimen which we have taken. So this is a microscope projector by using a torchlight. We will try another one. To watch the specimen of an onion layer, we have to take a layer from an onion and we have to place it on a empty slide. After placing it, we have to set in between this torchlight and to watch the specimen of an onion layer, we have to take a layer from an onion and we have to place it on a empty slide. After placing it, we have to set in between this torchlight and the eyepiece of the microscope, and we have to switch off our room lights. Then we can project the specimen onto the wall. Come back. ఇక్కడ నుంచి తీస్తున్నట్టు ఎందుకు So like this, we can show every child in our class. By adjusting this, we can project on a wall. At a time, we can show every children. Also, we can observe the refraction, and we can observe a total internal reflection in this slab. Total internal reflection. We can show total internal reflection of optical fiber cables also. So if you take the optical fibers, we can see the total internal reflection. light. Now I have taken a prism. By using this prism we can show the dispersion of light. I am making fall white light on that prism, so we can observe a rainbow. The VGR is formed on the other side of the wall. So this property of light we can explain as dispersion of light. By using plane mirrors we can show the children about the multiple reflection, multiple images we can make here. You can see multiple images whenever I am making those plane mirrors. So by using a piece of comb we can create rays. So by these rays we can explain the student the diverging and converging of lenses. I am sending light here by using a torch. So we can see here the converging rays. So this is biconvex lens gives converging rays, and if you take a biconcave lens the rays are diverging. So biconcave lens is a diverging lens. Thank you. Here I have taken a irregular rough surface. If you take it, the reflection is called diffuse reflection. If you take a smooth surface we can see the reflection very clearly. This is regular reflection. Reflection loss, I have taken a proper protractor here. If you send a light ray we can clearly observe it. So this is how this is normal line. We can take it as, if you take 10 degrees angle and 20 degrees angle, 30 degrees angle, so that incident ray and reflected ray we can easily observe and we can explain. Here I have taken a concave mirror and a convex mirror fixed by using a double tape. Then we can trace on a concave mirror. We can clearly observe the on a concave mirror the light rays converging at a point, and on a convex mirror the light rays are diverging. Can clearly explain the student the diverging and converging property of lights on mirrors. Here we have taken biconvex lens and biconcave lens. Now we can observe the diverging and converging properties here. Those two light rays are converging at a point, and here these light rays are diverging. Here we have taken a glass slab and a semicircular glass slab, and another slab is there. We can clearly observe the refraction of light here. The refraction of light bending when it is passing one medium to another medium on a glass slab. Here a semicircular glass slab also we can observe